I am Pınar Babalık, and this is the video presentation for my term project for magnetic resonance imaging course. I investigated the effect of a pulse sequence on magnetization. First of all, I started by developing the MATLAB tools necessary for me to simulate what I wanted to on magnetization. I came up with expressions for transverse magnetization, longitudinal magnetization, precession, and excitation. Now we are seeing what I have done in MATLAB so far and how I obtained the magnetization versus time plot. I'm showing both the longitudinal and transverse magnetization components. As you can see, there is an exponential trend. Secondly, I generated a pulse sequence in order to simulate the effects of sequences on magnetization. I first did the effect of saturation recovery and then the effect of spin echo sequences. Here you see what I expected to obtain out of saturation recovery magnetization, and these are my real results. When the signal is fully saturated and fully recovered, this is the plateau I obtained, and the first plot you see now is for partial saturation, so partial recovery. Later, I investigated the effect of a spin echo sequence, and my expectation was as follows, and this is what I obtained out of my simulations. Lastly, I wanted to investigate and focus on the real-life implications of pulse sequences. Pulse sequences generally have the effect of time of flight on magnetization and imaging. There are two types of time of flight effects on magnetic resonance imaging. The first one I'd like to talk about is the flow-related enhancement. The flow-related enhancement is a phenomenon in which, during spin echo imaging, inflow of spins results in an increased signal intensity. The effect is indicated by the blue arrow in the image you see. And the next one is the high velocity signal loss. The high velocity signal loss is indicated by the red arrow that you're seeing. And the flow-related enhancement actually has to do with the saturation recovery that we've just discussed. And then the high velocity signal loss has to do with spin echo imaging and how the pulses that are the 90-degree and the 180-degree pulses have such an effect on the image. In real life, the flow-related enhancement could be due to slow flow of blood in the indicated vein, and the high-velocity signal loss could be caused by rapid flow of blood in the indicated vein, conversely.